Hi, friends. This is John. Welcome back to the Regenerative Agriculture Podcast. I've been looking forward to our conversation today. I'm speaking with Lana Shaw from the Southeast Research Farm in, I think, Saskatchewan. I'm pretty sure in Saskatchewan. And one of the areas where there is so much opportunity for us to learn more is how we harvest sunlight more efficiently. For many of our agricultural areas, many of our agricultural practices and cropping systems, we have either periods of time or sections of soil even in the growing season that aren't photosynthesizing very well. And one of the concepts that I've been really intrigued by is the idea of companion cropping or relay cropping, whatever terminology you want to call it. So I've been looking forward to having this conversation to learn more about the work that you are doing in all the aspects that it relates to improving soil health and building soil and building productive ecosystems and productive management systems for the future. So thank you for being here. Can you tell us a little bit about the scope of your work and the story of your journey of how you got here and the scope of the work that you're doing today?
So I manage a research farm in southeast Saskatchewan. So we're growing crops outdoors, rain-fed agriculture, and trying to do experiments that are very applied and useful to the farmers. The organization is a farmer-directed nonprofit, so it's not a government organization, but we do get government contracts. So I started there in 2010, and I started looking into intercropping or companion cropping type of ideas very early on, basically as soon as I started, because I always liked the idea of that. I had looked into it in previous roles a little and it intrigued me, but I never really had the opportunity to start doing experiments on this until I had a research. Now, when I first started, the research farm was a very broke down mess and it had very little funding, and it was sort of a fixer upper, extreme fixer upper. That's over the last 14 years has been fixed up pretty well. So we've made a name for ourselves, or I've made a name along with Southeast Research Farm in doing cropping systems research pretty far outside the box. I often say that I lost the box a long time ago. So that still means that we're adhering to the scientific method, but how we're addressing those questions is maybe a little more imaginative than the more usual types of agricultural research. I come from a lot of generations of Canadian farmers. So the work I do is grounded in trying to make agriculture resilient, long term, sustainable, which is, I think I want to see agriculture functioning in a way that I would think is positive and healthy for the farm communities. Like, not just how efficiently can we produce grain, but are there actually farm communities that are persisting where the quality of life is good and the environment that those communities are in is healthy and not just driving people away and killing them. So that is what I see as sustainability in some ways.
What was the history of your original connection to the research farm? Did the research farm come looking for you, or did you come looking for the research farm?
They came looking for me. So it's kind of long story. I was in working for the provincial government in Outlook. I had quit that role after my first husband had died. I had two small children. I remarried and I'd moved down to the southeast Saskatchewan and was taking a little break from working. But I had a master's degree, and one of my previous government colleagues had come and talked to me and said, "We have this research farm that needs someone working there at least part time for now." And I thought, well, give it a try and we'll see what I can make of it. It was sort of a test for myself. What can I turn this into? I can prove myself or some of my. I wanted to see what I could do with it. And I think a lot of people would have wondered. what sort of purgatory I had gotten into at the time, or what did I do in my past career to deserve going to someplace this broke down and bad? Because at the time it was. So
Ay, ay, ay. So what originally was there original direction to look in the direction of relay cropping, or was this something that you brought to the research farm, and what led you down that pathway?
there was an influence coming out of Burleigh County in North Dakota, where some of my board was talking of my farmer board was talking about those guys in Burleigh County are doing cool things with tillage radishes, with some of the cover crop things. So there was a nice fit or alignment between some of my interests and some of the ideas that farmers were bringing forward. So I didn't have to really pull the farmers along on this. Over time, there's been different farmers come onto the board. Of course, we've have up to 9 farmers on board, and there's been a few times, not lately, where there's maybe one farmer that's kind of hostile to some of these things. Like they'd say, "Why are you doing intercropping? You should do more canola and wheat." And my approach was, the farmers already know how to grow canola and wheat. So why would I try to teach them how to grow canola and wheat in this region? They need to know how to grow other crops profitably to expand their crop rotations, not just grow 2 crops optimally efficiently.
I'm not familiar with the scope of the work that you've done over the time period that you have been there. What is the scope of your work today? How much progress have you made on the relay cropping or companion cropping, and what other projects are you working on?
So the scope is very broad. We're doing variety trials, product testing, the regular sort of agronomy things, but there's a component, maybe 20% or 30% of the program is these more biodiverse approaches. So cover crops and intercropping. So intercropping, the way we do it in Canada that works, is seeding 2 grain crops at a time and harvesting 2 grain crops together and separating the grain based on differences in size. We don't really have the length of season required to do the relay cropping unless that's extending over multiple years, where you have something underseeded, you have a main crop, something short seeded underneath that will persist longer after the harvest of the first. Done some of that type of work, underseeding, and then done research trials on cover cropping, where we were seeding cover crops after the main grain harvest in August or September. For 4 years, we did replicated research trials on that with Yvonne Lawley out of the University of Manitoba. And it worked a little bit, but we got relatively little growth. Would either have it was either cold and dry or cold and wet. We didn't get that combination of wet and warm falls very much during the years of that experiment. So it was a good test of the concept of how could we do cover crops in Western Canada. And what's kind of come out of it is that it makes more sense to underseed our cover crops if we're going to grow them. We seed them in the spring with the main crop and plant something that won't compete too much with the main crop, that we manage to keep it alive. It may not be happy, but it's still alive. And then after the main harvest is done, then you have something already established with a root system, with the ability to grow quite rapidly. And
What are some examples of the cover crops or the overwintered plants that you've found to thrive well in that environment?
so rye, it works fine. In some situations, there's clovers that work well, so a red or maybe a white clover. I think red clover is fairly commonly used. There's an Italian ryegrass that typically doesn't overwinter for us, and so it's basically a self-terminating or frost-terminated cover crop. In some situations, that can be really nice because we don't want delays in the spring on having to kill a cover crop before we seed, or it could be moisture in the spring that we can't really afford for it to be using. We have a big cover crop research project started lately where we seeded fall rye with flax. in the fall. The flax will winter kill. The rye was growing in the spring. We sprayed it out in the spring, seeded oats into it, and we're going to be checking what's the resultant yield and other growth characteristics of the oats if they had reseeded green into rye, basically, or were seeded on bare ground. So I've got an experiment with weather stations in it that will help us answer that. And the stations actually have moisture, salinity, and temperature sensors at 10 centimeter increments down to about 3 feet, or whatever that is, 90 centimeters or something like that. So that's a really neat trial that we've been able to just start since September last year. So that's some of the things I've been working on.
What have been the significant successes? What are the things that you have been able to study that you were able to identify as being successful that were then adopted by growers in the region?
One of the big ones has been chickpea flax. Now, it's not really broadly grown as a combination yet, but it's being more accepted as a reasonable method for growing chickpeas. Chickpeas are very susceptible to disease, ascochyta, and growing the chickpeas with the flax has reliably over years, and I've been doing this since 2012, reliably shown a reduction in disease, and we get a good stable yield. So there's not a yield reduction per se. Sometimes there's a yield increase, but there's a reduction in disease. So it makes the disease pressure less. It improves the maturity or the reduces frost risk of those chickpeas in our whole region and improves the quality of the chickpeas. So there's so many benefits to that combination that I'll be surprised if that's not the dominant method of growing chickpeas within 10 years. It's grown commercially, but it's not as though 90% of the farmers are doing it. It is established commercially, though.
Can you tell us a little bit about what this system looked like? What does planting spacing look like and relative seeding density now that you're planting both of them together? And ultimately, I think one of the
Yeah,
big questions that is really going to drive farmer adoption is what do the economics look like?
that's getting in the weeds some for sure. It's some farmers like the alternating rows, and when I say getting in the weeds, it's unsettled what the best way of doing it is. So some people like alternating rows. I prefer mixed rows. I've seen really good results out of mixed rows where we have chickpeas planted a little deeper than the flax using a double shoot, either a disc drill or a hoe drill. So we're getting them almost right side by side. The seeding rate of the flax is about 10 to 15 pounds an acre, which is maybe a quarter or less than a quarter of a normal flax rate. And then the chickpea rates are fairly close to a normal chickpea density, which is about 3 to 4 per square foot. So we were doing 10-inch row spacings. So the chickpeas and flax are right beside each other, and the rows are 10-inch row spacing. That's what we were doing for quite a lot of years in trials. We also tried alternating rows so that each chickpea row would be 20 centimeters. Now, in theory, maybe those wider rows would reduce disease, but in 2022, we're not seeing a reduction in disease from those wide row spacings. It looked better in the mixed rows. And we have not yet solved the mystery of why this is reducing disease. What's the mechanism? We have sensors out there measuring temperature and humidity in the canopy, and it doesn't match with humidity. You'd think we would be seeing less disease where the humidity is lower. That's not really what we're not getting those things to correlate, really. So there's something else going on. It could still be about the dispersal of the spores, or somehow it's changing the structure of the plant enough that it's less susceptible somehow. We were just out there doing meetings last week, and I don't know how it's turned out because I haven't done the analysis of those plants yet or on that trial yet. But it's an ongoing experiment.
You anticipated what my next question was going to be, which is, do you have any speculations on the cause of the disease resistance? But some of the things that we're learning with Dr. James White's work and some of his colleagues' work is that in a number of cases where we have these companion plants that generate disease resistance, it's actually an exchange of microbiome where perhaps the microorganisms from flax are colonizing the chickpeas and becoming associated endophytes, colonizing the entire structure and producing disease resistance. That's turning out to be a fairly common mechanism.
There's a pot experiment that was done as a grad student project at the University of Lethbridge with Dr. Monica Gorslak. And they were looking at split pots, so pots that would allow mycorrhizal fungi through, pots that would allow roots through, or pots that would just allow moisture through. Because I had this hypothesis that maybe somehow the flax is inducing resistance in the chickpeas, that it's tipping it off somehow. And there's ways of actually testing that, and scientists that are really excited about testing that idea. The soil biologists think that's really neat and are very happy to test that. So far we haven't induced that resistance with the method that they set up, but there's another little plan for how we're going to try this, and where we're exposing the flax to the disease of that causes problems in chickpea, and then letting it access through mycorrhizae the chickpeas and see if somehow there's some sort of messaging that's being passed on to induce resistance in the chickpeas. That's a hypothesis. It's not something that I can say that's what's happening, but it's a possible mechanism that there could be an induced resistance.
Yeah, that would be a fascinating experiment. That is one possible mechanism. Another possible mechanism tends to occur more with plants that are more aromatic, although all plants are to varying degrees. But that is also through just aromatic phytochemical signaling. But if that were the case, you would tend to think that the physical proximity, the close proximity of the plants might be less important. But that's fascinating. How, in this chickpea flax combination, how do the harvest economics work out for the grower at the end of the day?
So yield can vary some. The overall value of the crop is usually similar. So you get a little less chickpea, but you're getting some flax to make up for it. In years where the disease is severe, the economics of it looks very attractive because the intercrops will actually have a crop, whereas the monocrops, it will just fail. So it's very variable depending on conditions. The separation cost is relatively reasonable because there's screen type of separators can separate a very large chickpea out from a very small flax seed. That's probably so 25 to maybe 50 cents a bushel, but it usually can be done on farm without having to ship it off to somebody. So it's not a big cash cost for the farm necessarily, but it does take some time.
What, in addition to this companion crop combination, have there been any other combinations that you've been experimenting with?
Yes, lots. I wanted to plant camelina with lentils this year, but we ran up. It kept raining, and we didn't get that one in. But I have tried it. So camelina being a kind of an obscure brassica that has a long history in Northern Europe and is relatively new to the prairies in North America. And it grew very nicely with lentils, but I haven't had a chance to try it since 2022. What else? We've done some peas with oats. We're doing maple peas with canola this year, maple peas with mustard. I've tried a lot of different combinations. I like to do kind of shotgun trials when I have the available time and seed available, I'll just put a whole bunch of combinations of plants together in little plots and see how it turns out. And then I try to learn something by the end of it, and then that gives me maybe an idea of which ones I want to pursue more.
Of those various shotgun trials, what are some of the experiences that stand out in your memory as being particularly memorable?
The dry beans with flax was not good. I've been trying to find combinations with dry beans because I think it's a plant that's begging for a companion. It was grown in indigenous agriculture as one of the three sisters. It has potential to have agronomic benefits to having a companion, but I haven't been able to find anything that's really very suitable with the dry beans in spite of having put some effort in. The yellow mustard was probably one of the better ones, but you've got to have a variety of dry beans to go with that because the yellow mustard is matures quite rapidly. That's one I could try again with maybe with a one type of black bean that's in production here.
You've just preempted one of the questions I was about to ask, which is what have you observed that hasn't worked well?
Mhm.
But perhaps we could ask that question in terms of a combination, but we could also ask that question in terms of just approach or management practices. How are you thinking about not relay cropping, companion cropping today compared to a decade and a half ago? Has your thoughts and practices evolved at all in terms of how you're positioning seeds, planting densities, and so forth, just as a kind of a general overarching first principles perspective?
Like I started out just trying to find companions that worked well with each other. And at this point, I'm now that I've got a lot of experience of what plants can potentially go with what, most of my effort is spent finding the commodities where there's an alignment as far as end use, where a companion planting is actually seen as an advantage, where it'll have some marketing edge. So oats is an okay companion. It it's not even anywhere near my top five for what I'd like to put with a pulse, but there's enough demand for more ecologically friendly oat products that it's at the top for kind of emphasis for using this as a companion. Whereas canola works lovely as a companion crop for a lot of things, but the canola industry has had relatively little interest. Even a lot of the pulses that are going for export, there's not a lot of interest, hardly any interest from the commodity buyers, grain buyers in trying to obtain grain grown in this fashion or having a premium for grain grown in that fashion. So I'm sort of going from agronomy suitability to marketing strategy for where I'm trying to find research funding. Because if we find research funding, we have to find industry that will get behind us, or commodity groups, or some sort of strategy edge in order to be able to get that research funding.
You mentioned canola being a great companion plant and that the industry hasn't been particularly interested and hasn't adopted that. What about and maybe you're implying this already, but what about the farmers and the growers themselves? If there are agronomic advantages for them to grow a companion plant with canola, why would they not choose to do that?
It depends on the relative price of canola to other things and the opportunity cost of just growing canola on its own, because they may, a lot of years, make money growing canola on its own compared to growing canola with, say, peas. So, and you might not get a lot of canola if you grow canola with peas. You might get only a third of a normal yield and a lot of peas. Well, to a lot of them, that doesn't really seem like a good use of their that slot in the crop rotation. Or they're planning to grow canola and peas, so putting both in the same year is leaving a gap in their crop rotation. So that sometimes gets into it. There's also herbicide issues where there's one herbicide package, the Clearfield types in canola, that works with growing it with legumes, but that's not the types that are typically grown. The ones that are typically grown are the Liberty or glyphosate tolerant ones that have shatter tolerance. So that's actually one of the things that's holding it back. The genetics that we can use with the intercropping with Clearfield herbicide system, it doesn't have some of the latest GMO bells and whistles on the shatter tolerance, or there's probably other things as well, some of those other traits. And there hasn't been that much investment into that Clearfield platform for, seems like, for a lot of years. Most of it's going into the Liberty and glyphosate ones. So
Sometimes we observe these situations with companion plants where 1 + 1 does not equal 2, or a 50% and 50% seeding rate doesn't equal 100% yield, but there's this additive or compounding effect where you produce a much greater yield response or disproportionately large yield response for the quantity of seed that you actually applied. What are the combinations that you have observed this with, and what are the plants that tend to grow very well together?
so if I'm looking for something that will over yield, because that's what you're talking about, is over yield, I'm trying to find things that have some sort of agronomic limitations, like they're short, like lentils, for example, or they tend to lodge, like peas, or they're already not terrifically high yielding, like mustard. So you put something together, like a mustard with a lentil or a mustard with a pea. I've had over yielding of 30%, 20, 30% on that, and economically very attractive outcomes with something like that, because it hasn't had the sort of optimum, like, capturing genetics that some of the cereals have. Even canola as monocrop it's just a rather tremendous plant for being able to capture sunlight, at least for a fairly short period of time in the summer. It's quite competitive. Some of the ones that I think there's more potential for is the more wild types, if you could call them that, of peas. So your leafy peas, your forage peas, the maple peas, the ones that are obligated to climb, or they have the genetics for climbing. So you put it with a plant that will act as a scaffold, then you've created a sort of a symbiosis, designed a symbiosis. And if those can be plants that are high value, and oftentimes they are, then economically that's very attractive.
Of your wide range of experiments where you've tried this general shotgun approach, you mentioned one specific instance. What are some of the things that haven't worked well?
Well, some of the things were hard to separate. So split peas or split lentils, or trying to separate that from oats, was a problem. I one time tried a triple intercrop with peas, lentils, and yellow mustard. And the lentils I was using was very small, and I wasn't actually able to separate them adequately from the yellow mustard, which wasn't really what I was expecting, but there just wasn't quite enough size. I've had it before where we were in peas and canola, and I planted it on land that was in peas 2 years previous. I didn't know that. It was rented land, and I guess I didn't ask enough questions. So we had canola going with peas, but the peas were very sad. And so I had a not very good canola crop with a few tiny peas growing underneath it, and they didn't do good. But that's okay. It's better off I have a little failure than the farmers. So that that sort of answered the question: does intercropping solve root rot problems? Well, unfortunately, no, it doesn't. It may mitigate it somewhat in some circumstances, but that, sometimes we learn things the hard way.
Can you tell us a little bit? We've been so far in our conversation, we've been focusing on companion planting. Can you tell us a bit more about the scope of your work outside of that?
I've been working on a lot of specialty crops. So camelina, flax is sort of a specialty crop. Some of these minor crops that are grown, and that's been a priority that we maintain them in the program. Sunflowers for us is a fairly minor crop, canary seed. So doing both the agronomy work and the variety development work so that when people decide, hey, maybe I want to grow mustard or I want to grow rye or something like that, that we've already done the work of the agronomy and the help develop some of the genetics. Now, when I say help develop the genetics, that's basically advanced field trial. We're not doing the breeding, but the breeders will send us materials for evaluation, and we send them back the results. We might send them seed samples, but we don't have to do the segregation that you would if you were relying on that seed for your breeding materials. Really helping evaluate their advanced lines. And so there's quite a big program either before pre-registration with the breeders or after registration of those varieties to determine which ones are performing well or not in our region.
When I think about the very multifaceted nature of the work that you're doing and being a research farm, there is this challenge that I'd love to get your perspective on. We have in this different approach, this different mindset of developing agricultural systems, which takes the ecosystem into consideration, takes soil health into consideration. As we seek to develop these different cultural management practices and these different systems, and as we develop an appreciation for how interconnected everything is, it becomes very difficult. The very idea of single factor analysis becomes increasingly more challenging to the point of, as I forget who perhaps Gandhi, the quote is originally attributed to, that when he tries to move one thing, he discovers that it's connected to the entire web of life. I think once you really start digging into soil biology and looking at how everything is connected, then you realize that it's literally impossible to change just one thing. Because when you change one thing, then everything else changes. So within that framework, how do you think about research and putting together scientific methodologies that are inherently multifactorial rather than single factor?
It's very common to have more than one factor in the sort of traditional small plot research trials that we have, but it might be only two or three factors. It's very common to have more than one factor, but that's still not super complex compared to, yes, there's enormous complexity in the environment that we could look at. What we have to be able to do in order to do science is say, I have a question about this. How would I go about setting up an experiment where it will help me answer that question? So, for example, I came up with a project for testing the use of humic acid as a nitrogen stabilizer. Now, the humic acid's in use among the soil health circles for many, many, many different things. I don't know how many various different things it could be doing, but I'm going to design an experiment where I will check, does it have value in making the nitrogen fertilizer more efficient? So that's my question. Now, what else it could be doing as is like I'm treating as that like it's a bonus. I have no reason to think it's a big negative going into the soil. So anything anything else that's benefits is a bonus as far as me trying to answer that question. So if I can say at the end of this experiment that the humic acid improved the nitrogen sufficiency of the fertilizer that was going down, and there's some reason to think it might. There's a lot of people claiming that it is, but not a lot of good proof that it does. A little bit. So we're testing that. Now, if we can show that that helps, that can make an enormous difference on not just the sales of humic acid, but it's a win-win for the farmers and for the environment. So that's it. We're looking at designing something. where we can test that. And we're comparing it to the chemical nitrification inhibitors. So the chemical enhanced efficiency products, comparing with plain old nitrogen going down, humic acid with the nitrogen, and then these chemical enhanced efficiency products. And then stacking them all.
You're referring to materials like urease inhibitors and nitrification inhibitors and so forth.
Yes. So if we put humic with the urease inhibitors, is that even better? Does the humic do an equivalent job, and under what conditions? I don't know, but we've got an experiment on the field right now that's trying to answer that question. So with a given experiment, I can't answer all of the complex questions that come up that could touch on that subject, but I can design a project that will help answer the question. And I think a well-designed project or experiment will accomplish something. But no experiment is going to give you the complete picture. So it's sort of like, here's a little piece of the puzzle. I can put that into place. And we can do a different experiment that will put another little piece of into place. So then gradually the picture gets clearer over time. And then you stand back and go, okay, that's how we get more clarity on the bigger picture. That's how I approach it. That I don't think I'm going to, oh, I'm not trying to oversimplify things. I'm trying to put in little pieces here and there in the bigger picture.
What is it about your work that you would like farmers and growers to know about more broadly that we haven't touched on yet?
It's hard to get funding for some of these types of research because it's not seen as very mainstream, or it's not seen as something that your large scale farmers will take and run with successfully. The commodity groups tend to be a kind of a small c conservative, stick with the main herd kind of idea, and not usually that aggressive on being out on the where the cutting edge of ideas are. So if the farmers can help to advocate for, we're interested in this type of research, we actually want to implement this on our farm, we want to understand how best to do that, or what's the most efficient way of doing such and such. The farmers have quite a bit of influence on being able to swing, or is there funding getting to some of these type of strategies? So instead of saying, well, researchers don't want to work on it, try to find researchers that do and try to help them access money. Because people will say that researchers don't want to do it. Well, the researchers follow the money. And if we keep getting shut down over and over and over again, but we can get trials to do fungicide work all day long, well, researchers need to be able to get funding to do so that end up following money where funding is.
Where can people learn more about your work?
There's some of it on Twitter. There's not enough of it on our website. We do have a website, the Southeast Research dot, and I'm not sure where else. I do show up on podcasts and videos every so often, and I'll be in Edmonton at there's a Regen Ag event in Edmonton this December, I think it is. So I'll be there talking about all my things.
I might get to meet you there. I think I'm also supposed to be there if we're talking about the same event anyway.
I'm pretty sure we're talking about the same event. So yeah, I'm on the ticket on that one, so they can learn about that there. Some of the research is getting published in scientific journals, so they can search up my name on some things, and they could find some of that research. I need to post it on our website so we have those new journal articles. But I tend to post Twitter/X fairly reliably, so some of the links to different things are accessible there.
Wonderful. Well, thank you for being willing to jump on and share the work that you're doing. Thank you for all the work that you continue to do. And I wish you continued funding and research success.
Thank you.
The team at AEA and I are dedicated to bringing this show to you because we believe that knowledge and information is the foundation of successful regenerative systems. At AEA, we believe that growing better quality food and making more money from your crops is possible. And since 2006, we've worked with leading professional growers to help them do just that. At AEA, we don't guess, we test, we analyze, and we provide recommendations based on scientific data, knowledge, and experience. We've developed products that are uniquely positioned to help growers make more money with regenerative agriculture. If you are a professional grower who believes in testing instead of guessing, someone who believes in a better, more regenerative way to grow, visit advancingecoag.com and contact us to see if AEA is right for you. Thank you for listening, and we look forward to working with you.